Next I am discussing some of the formula related to spherical mirrors. The first formula is the relationship between the focal length and the radius of curvature. For every spherical mirrors, all spherical mirrors are having radius of curvature and focal length. What is the relationship between focal length and radius of curvature? Focal length is half of the radius of curvature, or the radius of curvature is twice the focal length. So you know that what even by radius of curvature? Radius of curvature means it is the distance from pole to center of the mirror, pole to center of that sphere, pole to that center of that sphere. So that distance is known as radius of curvature. Radius of curvature is the radius of the sphere. And focal length. So focal length and radius of curvature, this is the relationship. Focal length is the half of the radius of curvature, and radius of curvature is the twice the focal length. So f equal to r by 2 or r equal to 2f. Next, the mirror formula. Mirror formula is 1 by v plus 1 by u equal to 1 by f. V is the image distance. Image distance, it is the distance from the pole to image. All distance we are taking from the pole. So V is the image distance. It is from the pole to image. U is the object distance. It is the distance from pole to object. And F is the focal length. And this formula is known as mirror formula. That is 1 by V plus 1 by U equal to 1 by F. Then magnification. What do you mean by magnification? You know that concave mirror produces enlarged image and convex mirror produces diminished image. So it is a comparison of the size between the object and image. So magnification is the comparison between the size of the object and the size of the image. If the size of the image is more than the size of the object, you can say it is magnified. It is magnified. The image is magnified. If the size of the image is less than the size of the object, then you are saying the image is diminished. So magnification, it is a comparison of the size between the object and the image. How can you find out magnification? By the height of the image and height of the object. H2 is the height of the image, and H2 is the height of the image, H1 is the height of the object. V is the image distance, U is the object distance. Or there are two formula, magnification equal to F divided by F minus U or F minus V divided by F. So these are the different formula for finding magnification produced by spherical mirrors. It can be in terms of the height of the object and height of the image, or it can be in terms of image distance and object distance, or it can be in terms of focal length and object distance, or it can be in terms of focal length and image distance. So these are the main formula related to spherical mirrors. So F is the focal length of the spherical mirror, R is the radius of curvature of the spherical mirror, V is the image distance, U is the object distance, F is the focal length, H2 is the height of the image, H1 the height of the object, V object image distance, U object distance, F focal length, U object distance, V image distance. So these are the main symbols we are using in the spherical mirrors, which are the F, that is the focal length, R radius of curvature, then image distance, object distance, then height of the image and height of the object. So these are the main variables in the case of spherical mirrors, and by connecting these variables we are forming these equations. So this is important, mirror formula and magnification and the relationship between radius of curvature and the focal length. This is an explanation of the magnification produced by the spherical mirrors. Magnification has a magnitude and a sign. Sign can be plus or minus. Magnitude represents size of the image. Sign represents nature of the image. If the sign is positive, the nature of the image will be virtual. If the sign is negative, the nature of the image is real. Then, what about the size of the image? If the magnification is less than 1, that means it is a diminished image. If the magnification equal to 1, that is the same size of the image. If magnification greater than 1, that is a magnified image. So this is a clear understanding of magnification produced by a spherical mirrors. You know that magnification tells what? About the nature of the image and size of the image. Nature of the image can be real and virtual. Size of the image can be higher, equal or smaller. So magnitude of the magnification tells if the magnification is less than 1, that is the diminished image. If the magnification is equal to 1, that is the same size of the image. If the magnification is greater than 1, it is a magnified image. What about the sign of magnification? What tells about the sign of magnification? It represents the nature of the image. Plus positive sign indicates the image is virtual. And the negative sign, negative magnification indicates the image is real.